Okay, good morning. So today's lesson we're going to focus on Boolean expressions, Boolean operators, and be able to use them in flowcharts and in Python code. So we're going to focus on what Boolean means. So Boolean is named after a mathematician called George Boole, who was way ahead of his time. In the 1850s, he came up with the science of reducing the numbers that you have to deal with down from 10 to just 2, true and false. And even though computers didn't exist at that time, he wrote a hugely influential paper that most people ignored at the time. But when computers came along with digital switches, so transistors, a transistor is just a digital switch that is either on or off. But most importantly, that on and off can then be connected to control another transistor. And if you connect lots of transistors together in a clever way, you can make logic gates. And logic gates can do things like and, or, and not. And if you collect logic gates together, you can make CPUs or GPUs or any type of processor. So George Boole's input and influence on computing meant that we can now predict with accuracy how any computer is going to behave. So today is all about logical operators. We've talked about Boolean expressions before. We've talked about Boolean data types. What we're moving on to is all about all about using and, or, and not in our programs. So we need to talk about truth tables. A truth table is a way of simplifying pretty much anything, as in the world is a complicated place at the moment. All families are trying to work out what do we do at Christmas? What Christmas present should we buy? Which family are we going to invite? Are we going to be in lockdown or are we not? Life's decisions are difficult. Logic decisions are dead simple, because they have to be, because computers are stupid. I'm sat in a room full of very intelligent, articulate, creative people. You can make complicated decisions. You do them thousands of times every day. Computers have to be able to break it down to simple yes, no decisions. And they do that with logical operators like and, or, and not. The idea is, if you know what inputs you've got, you should be able to predict with certainty what the output is. As in, it's not just somebody who decides randomly what the output's going to be. A computer should be able to run the same program 1,000,000 times and come up with the same answer 1,000,000 times. So this truth table tells you the truth. It says, if input A is on and input B is on, then the output is also on. But any other combination of the inputs, if they're both off or just one of them's on, then the output is also off. So we've got an OR gate as well. An OR gate is always on the output unless both inputs are off. For example, you can have both inputs on or either or the inputs on, but if both of them are off, the output is off. And then the NOT gate is the easiest one to remember because you've only got one input, and it's an awkward little, I was going to swear then, an awkward logic gate. Because the output is always the opposite. Whatever the input is, the output is the opposite. So that's nice and easy until you start combining them. So here we have a number of comparison operators which will give you a Boolean expression. For example, 3 is not equal to 4. Well, yeah, we know that. We know that 3 is not equal to 4. So this first bracket here is true, because 3 is not equal to 4. That's where we get the true from. Then we have another bracket. 5 is less than 6. Well, yes, 5 is always less than 6. So that is true. And then we have the OR. So true or true, if we go back to our OR truth table, true or true, yes, we get the output as being true. So just like in maths, when you have BIDMAS or BODMAS, the order of operations is important, as in you do the brackets first. So here we have a few more to go with. So here, the order means we have to do the NOT first, and then we take the result of the AND. So NOT A and B. Let's have an example. First of all, if you've got two inputs, you'd work out what NOT A is. NOT A is just the opposite of A. You can see here, 0 is the opposite of 1. And then you have to AND this column, NOT A, with B. So we've got not A and B. The output here is likely to be a 0, or has to be a 0, because in order to get the output of 1, we need both of these columns, that and that. So let's have a look if we put the output column on there as well. I was expecting the output there. Never mind. So let's start on, sorry, I'll pause it. And for CT10, you have and, or, and not. You need to fill in the gaps to say which one of these has exactly 2 inputs. So there's 2 here. One of them has just 1 input. One of them returns true if both conditions are true. That's not true. 2 of them do. One of them returns true if either conditions are true, and only one of them. So you just got to label 1 or 2 logical operators. I'll give you a few minutes to go and then we'll pause for some questions. So we're going to go through some of the answers here. Here you either have to write in 1, 2, or 3 of our logic operators. A logic operator is something that can work with true or false. So 2 of these have 2 inputs. An AND can either have, well, it can only have 2 inputs, like A and B. So AND has 2 inputs. OR also has 2 inputs, because you can have A or B, as in, is it raining or is my umbrella up? AND has 2 inputs, like, am I hungry and do I have enough money to pay for a takeaway? Takes exactly 1 input. Well, AND has to have more than 1 input, because you can't have one thing and it just leaves you hanging. That has to be not. And not only has 1 input, and the output of that is the opposite of the input. Returns true if both conditions are true, so that needs to be and. So if I'm hungry and I've got money to spend on a takeaway, then I'm going to order a takeaway. If I'm not hungry but I've got the money, then why would I waste my money? If I'm hungry and I haven't got the money, then, well, I can't buy one. I have to have both. And means you need both inputs to be true to have the output to be true. This one, I'd argue, is both, and or. Because if you have either being, oh no, that's not right. Sorry, ignore me. It has to be or, doesn't it? Because you have either of them. Yeah. And then this last one is not. Hang on. So for the next ones, a 0 represents electricity switched off, a transistor switched off, binary 0, and also represents false. So here it's representing an input that is switched off. The question says it's an and statement. So if I'm not hungry and I don't have any money for a takeaway, I'm not going to order a takeaway. If both inputs are 0, the output to an AND gate is a 0. For an AND gate, the only way the output is going to be a 1 is if both inputs, input A and input B, or input 1 and input 2, doesn't really matter. That's the only time when the output is going to be a 1. And then the next one is the same kind of thing, but just using true and false instead of 1s and 0s. So for an OR statement, if you've got either or input, then the output is going to be true. But if both inputs are false, the output is going to be false. What's the point of all of these? Well, number one, you've got to remember these truth tables. They're actually really easy to remember. I don't remember the whole table. I just remember the fact that for an AND gate, you need both inputs. And for an OR gate, you need either or. The important thing is, this is the building block for all digital electronics. If you connect logic gates together, then you can make a CPU, you can make RAM, you can make pretty much anything inside a computer from these logic building blocks. So let's have a look at activity 2 together. This is a prediction, and then I want you to test it with Python. So remember, you do your brackets first. This is a Boolean expression. Boolean means true or false. This is a Boolean expression. Boolean means true or false. And then if you take both Boolean expressions and use an OR logic operator, then the result is also going to be a Boolean expression, true or false. So let's see. Is 78 equal to 10? No, it's not. We'll have a false. Then we'll combine that false as one input, and the other input is going to be, is 6 equals 7? No. So we've got false or false. Both inputs are a false. The inputs go into an OR gate, so the answer is going to be false. How do we check? Good question. So we go into your IDE of choice and either type it out with a print statement or put it in the REPL. The REPL stands for read, evaluate, print loop. So if we just run this, I'll have to save it as something. .py, and then if we run it, nothing will happen. But if we print the result, we'll see something. So it says false. Alternatively, you can just type it in the REPL, the read, evaluate, print loop. It's just a loop that constantly gets you to type stuff in, it evaluates it, runs it, and then prints the result. So if we just paste in that, you'll see that that's false. Don't cheat though. Predict first, test afterwards. So activity 3 requires a fair amount of patience, a little bit of brain ache, and definitely a pen and some paper. So we have a truth table here and a complex Boolean expression. So let's count and spot the logical operators. We have not, we have and we have or, and we have lots of brackets. So we need to work out which order to do these. So you do the inner brackets first. So first I would work out what not valid is, because that's a bracket inside a bracket inside a bracket. Then I'd work out whether not valid or key equals k, I'd work out what that is as a Boolean expression. And then that expression I'd put as an and with count is less than or equal to 15. So we have to do it in that order. So you start in the innermost bracket and you work your way out. So let's see. If valid is 0, not valid is the opposite. It's going to be 1. So we can work our way down and just invert them, the opposites. I'm not going to do them all, let you do that yourselves. Then we've got not valid or key is equal to k. Well, we've got both inputs here. Key is equal to k. In this example, no. Not valid. In this example, yes. This column then is just ORing these together. Have we got either this column or this column? Yes, we have. Have we got this column or this one? Yes, we have. We've got both. Have we got this column or this column? No, we haven't. We haven't got either. So then, this column, not valid or key is equal to k, that's this. Sorry, come on, words, behave. So the previous column is what I've highlighted here. And then I've just got to AND that with the very first column. Is count less than 15? So, is count less than 15? That's a 0. And then not valid or key equals k is a 1. And they're combined with an AND logical operator. So AND means we need both. Have we got both that and that? No, we haven't, so therefore it's a 0. Have we got that and that? No, we haven't, so therefore that's a 0. Have we got that column and that column, or that input and that input, or that expression and that expression? No, we haven't, so that's a 0. I'll stop there, I'll let you do the rest. So for activity 4, we have to predict what we want to happen first, and then we'll copy and paste it into an IDE, and then test our prediction afterwards. So let's have a look at the program. We have a variable that's set to 1, a variable that's set to 0. We've got a variable that asks the user a question. Input always returns a string, but then it's converted to a float, which means a decimal number with a decimal place. Then we ask how many missed assignments there are. So it asks a question, it converts the answer into an integer. And this is the important bit. So we've got some inputs here in our test table. So if the user says that attendance is 0.9 and that missed assignments is 1, we have to work out whether the program will say pass or fail. So let's have a look. Is attendance greater than or equal to 0.85? Yes, it is. Is missed assignments equal to 0? No, it's not. And with an AND gate, if either of these are a no, a false, a 0, then the output has to be a 0. So is that true? Yes. Is that true? No. Is that And that, no. So therefore, it doesn't run the if code. It skips on to the else code. That's my prediction. It should say fail. And then you can copy out the code and see if it works. If and when you've finished, here's your extension. I'll just pause it whilst I write it and then I'll explain it. So, just before we finish off and submit, it's worth having a look at page 14 in your Clear Revise textbook. We've talked about logic operators in Python. They link really nicely with logic operators in electronics and truth tables in topic 1. So, in Python, we've got an AND gate, an OR gate, and a NOT gate. We know that an AND gate has 2 inputs. We often call them A and B. An OR gate has 2 inputs, and a NOT gate only has 1 input. On web pages, you often see Q or O as the output. I'm going to put Q. And a NOT gate only has 1 input, but also has an output. I'm going to write these as binary, just so that you can see what they are. So this kind of explains what happens on page 14 of your textbook, your revision book. So there are different combinations, and normally you write these in binary order, as in 0, 0 is 0 in binary, then you'd write 1 in binary, then 2 in binary, and then 3 in binary. So an AND gate, you have to be able to fill out this table. You might have an exam where you're asked to complete a truth table for an AND gate. Don't need to remember the whole thing. Just remember that it goes in logical order, numerical order, binary 0, binary 1, binary 2, binary 3. And an AND gate needs both inputs. So you only have a 1 for the output. So that is the only line you need to remember for an AND gate. Help. Where's it gone? The others are all zeros because you haven't got both inputs. An OR gate, again, you write them in the same order. So we've got 0, 1, 2, 3. And you have a 1 almost all of the time. If you've got either input, then your output is going to be a 1. So the only one you really need to remember for an OR gate is the fact that if both inputs are 0, then the output is 0. And a NOT gate is dead easy. You've got 0 or 1, only 2 possibilities because you've only got 1 input, and the output's the opposite. So you need to remember what the logic gates are called, or the logic operators are called if you're using them in Python. You need to be able to remember the truth tables, and you need to be able to remember the diagrams. So here's a quick way to be able to remember them. So an AND gate with 2 inputs, they don't have to be called A and B, they can be called whatever you like. They can be called raining and umbrella. But we tend to call them A and B and an output. I remember it as the D of AND looks like the shape of your AND gate. The next one, you have an OR gate with a sharp point, 2 inputs going in, 1 output coming out. I remember this, that it looks a little bit like a rocket going into orbit. That's how I remember it. It looks like a little rocket. Or, if you get confused by that because you think the D from AND also looks like a bit of a rocket, you could remember it by that part of the O looks like that part of the OR gate. Don't really mind. Point is, you need to remember the shapes for both an AND gate and an OR gate and different possibilities of your inputs and outputs. A NOT gate only has 1 input, so it's easy to spot. So we just have a triangle here with 1 input and an output. And this little blob here means it's an inversion. It's like an awkward thing on the end. So I remember it like a spot on its nose. And if I have a spot on my nose, I'm going to be in a bad mood and I'll say the opposite of everyone else in the room. So if it has a little spot on its nose, it says the opposite of the input. I don't know if that's helpful for you to remember it, but that's how I remember each of these. The D from AND, the O from orbit, and the NOT with a little spot on its nose. Okay. When you've finished your Word document, it needs to be submitted on Algorithms and Programming 2, please, so I can mark it and give you some feedback for next time. Thanks very much. All the very best.